All right, let's get started. So as I promised, right, I'm turning over a new leaf. Instead of jamming you new material, we're just going to go over the test, answer any questions you have, and yeah, feedback, whatever you have. I'm just putting this up here. This is, you can see the max min as well as the average. So it was an 88. This is in Brightspace, and this includes everybody's grades. I'm obviously not going to show you everybody's grade, but if you look over here, you can see the distribution. So the vast majority here got between 75 and 110. So you can take a look at the percentages from there and make your own decisions about how you think you did and all that stuff. So let's go over the exam. All right, first question. Really don't like, hard to operate with podium here, but okay. So we have an f of s equals to 4s plus 13 all over s cubed plus 6s squared plus 13s. Find f of t. So what we need to do, right, is we need to make it look like the Laplace tables, and you were provided the Laplace table. So all you need to do is just make it look like that and then bring it back to the time domain. You don't have to use that integration formula that we provided, back in the first week of classes. But the first thing we can see here is we have an extra s term in here. So we're going to factor that out. And now you can either use roots or the quadratic equation. So do your complex roots or whatever. I'll just do the quadratic equation. So we have negative b plus or minus the square root of b squared minus 4ac. So 4 times 13 is 42. Yeah, no, 52, sorry. All over 2a. So that becomes negative 3 plus or minus the square root of negative 16, right? Which is 4 times I. Divide by 2, or 4j, which is equal to negative 3 plus or minus j2. So my f of s is going to be equal to 4s plus 13 over s. And anytime you have complex roots, my suggestion is, and a lot of people forgot this, is you use the negative real part and do it that way. A lot of you people tried to go, oh, well, f of s is equal to 4s plus 13 all over s times s plus 3 plus 2j times s plus 3 minus 2j, which is perfectly fine. But the problem is when you go back into the time domain, this is e to the minus 3 minus 2j. Now, let me put it over here. E to the minus 3 minus 2j, all of that is multiplying t. Can you put that in Excel and get a realistic time domain response? Not a tough question. Yeah, because you get j, and j by itself is an imaginary number. There is no such thing as a square root of -1. It's just a mathematical construct to be able to do the math. But when you had an e to the minus 3j, and then you added an e to the minus 3 plus 2j, you could actually combine those using Euler's identity to get a sine or a cosine. So this was not an acceptable answer to have a bunch of those numbers because that's not a real number. Now, some people also did f of s when they did partial fraction expansion. They did a over s plus b S plus C all over this. And that was fine. You would have ended up with some sine and cosines, but that's perfectly fine as long as you did it correctly. It's just more work, in my opinion, because you can't use our techniques. So if that's what you wanted to do, I don't have an issue with it. As long as you showed your work, that was okay. What I taught you in this class is to go with A over S plus B at an angle of theta over S plus 3 squared plus 2 squared. So that's what we'll show. A is going to be equal to 4S plus 13 all over 6 S squared plus 6S plus 13 evaluated at S equals 0. And when I did that, I ended up with 1. And B at an angle of theta is going to be equal to 4S plus 13 all over S evaluated at the negative of the complex root. So minus 3 plus the positive of the 2j. And when you did that, you ended up with 2.24 at an angle of minus 63.4 degrees. So my partial fraction expansion term is going to be is going to be 1 over S plus 2.24 at an angle of minus 63.4 degrees over S plus 3 squared plus 2 squared. But remember, to go ahead and have the sine term in the table, I have to have omega here in the denominator, in the numerator. So I put a 2 over there. Don't forget I have to divide by 2, right, to make sure I'm multiplying by 1. So my final f of t, this is a unit step, 1.12 e to the minus 3t sine of 2t minus 63.4 degrees.
Equal that to just other because of that too.
This 2 right here? Yeah, so I know I need the actual expression in the time domain is the sine of omega t. E to the minus alpha t sine of omega t is going to be equal to omega over S plus alpha squared plus omega squared. That's what the equivalent is. I've got to have omega over here. I don't have omega, I have 2.24. So I know I've got some additional number in there. So what I do is I just like, well, I'm going to put 2 up there, which means I'm multiplying 2 by 2.24. So the only way sure that I don't change the result is I'm going to divide by that same number, right? These 2 will cancel each other out, won't they?
So
You can put any number you want. And that's number 1. Questions on number 1? Fair or not fair? But it's great, not unreasonable. Any other comments or thoughts on that? Or wasn't meant to be a tricky or hard problem. It was just a review of what we did last semester. Yep. Is this when we make him do the walk of shame? Think. Sorry, it's just a lot of pages. Hold on. I think this is all your pages. Okay, number 2. F of S is equal to S squared plus 2S all over S plus 4 times S squared plus 6S plus 34. Draw the pole 0 map. So the thing you need to do is solve for the roots, both in the numerator and the denominator. So we got to do a little bit of math. We know that this is S times, excuse me, S plus 2 So that's already factored in as much as we can. Over here, in the denominator, we've got another problem that we need to do. So let's go ahead and do the quadratic equation. So negative b plus or minus the square root of b squared minus 4ac. So 4 is 136 all over 2a. So that's negative 3 plus or minus the square root of 100, negative 100 is 10j divided by 2. Okay. So again, we just use our standard form, s minus the real part, quantity squared, plus the omega part squared. So now I can look directly at this and I can see what the zeros are, the roots of the numerator. And we have 0 and minus 2. The poles are the roots of the denominator. And I have negative 4 and negative 3 plus or minus j5. Everybody agree with that? Well, what's the definition of a 0? A 0 is not the roots of the numerator exclusively. The 0 is when evaluated at s equals 0, f of s equals 0, right? It's not just the roots. It's also, what if I allow what happens here? I just have to focus on the highest order s terms, right? What happens as s approaches infinity? Goes to 0. So don't I also have one at infinity? And if you remember when we talked about pole and zeros, we always said that the number of poles is always going to be equal to the number of zeros when you include any infinite poles or zeros. Well, because we got really good at using limit functions, right? So if you remember last semester, I would say finite poles and finite zeros. But when we include all the poles, they're the same. Do we have 3 here? 1, 2, 3. 1. The plus is 2. The minus is 3. So it checks out. The number of poles and the number of zeros is the same. So now for my pole 0 map, and there were surprisingly struggles with the actual drawing of this. The zeros, you have one over here, one over here, and you probably have one over here, but it could go in the other direction too. It could be negative infinity, you don't know. But for now, we'll assume that it's going to be in the left-hand half plane. Over here, negative 4. And then we have complex conjugate pairs. Okay, these should line up. Some people had real struggles with plotting those on the graph. You know that you have to have a plus j term and a minus j term. You can't have one without the other. So if you have complex numbers, what I'm saying is this can't exist by itself. That doesn't exist. Okay. Questions on that? Fair, not fair? People are more quiet on this one. What about this particular problem? Was it tricky? Okay, it counts, right? So, whoop. All right, number 3. So this is an op-amp circuit, and the way that I did this, the way that I'm going to draw this, instead of having to write all those resistors, I'm going to go ahead and immediately convert them into inverting op-amp configurations. So I have that first stage, and instead of having the R1 and the C1, I'm going to show it as a block of Z1. Here's my input voltage.
You've done this during the exam?
Yeah. That's what I did. Then I have R3. And R4, and this is V out. So I'm going to put an intermediate stage. I'll call this VA. So VA is equal to negative RF over RI. You don't have to do any derivations. You just did negative RF over RI. So negative V in times Z2 over Z1. RF over RI is the same thing as ZF over ZI, or Z2 over Z1. And V out is going to be equal to negative VA, which is our input to our second stage, times RF, or R4, over R3. So now I want to go ahead and get V out over V in, so I have to stuff that in there. So V out is going to be equal to minus V in Z2 over Z1. All of that is times minus RF, R4, over R3. That's going to be equal to, the negatives will cancel. So I want the V out over V in equals Z2 RF over Z1 or R4 over R3. Now I've got them in terms of Z's, but my original circuits had resistors and capacitors. So my Z1, R1, what is a capacitor equivalent to in the Laplace domain? So Z1, which is the equivalent impedance looking across those two, is going to be equal to R1 plus 1 over C1S. And then I just put that under a common denominator, just to make it a little easier. My Z2 is going to be equal to a capacitor and a resistor in parallel. So my Z2 is equal to product over sum. So R2 again, common denominator. End up with that. So now I just need to stuff those into here. And I have, let's see, R2 over R2 C2S plus 1. And that gets multiplied by R4 all over Z1 R3. Okay. Now I invert and multiply. So I have C1 R2 R4 S all over R1 C1 S plus 1 times R2 C2 S plus 1. That's it. That's as far as you needed to go. You certainly could have factored out and made them all multiplied by ones, but I said, I just don't want fractions within fractions. So this is just a bunch of algebra. Questions on number 3? Fair, not fair? It's a lot of work, but it was algebra. Makes math a lot easier, doesn't it, when you just stuff them in at the end? It's a page and a half?
I mean, big writings.
Ah. Any other questions or comments on number 3? No? Okay. Number 4. So number 4, you were given a differential equation. X triple dot plus 6x double dot plus 11x dot plus 6x equals my 6 times my input. Find the transfer function, which is the output over the input, what R was the input. So the first thing I do whenever I ask for transfer function is I go to the Laplace domain. So this is s cubed multiplied by x plus 6x squared multiplied by x plus 11 multiplied by x, 11s, sorry. And then this is 6 multiplied by x equals 6 times r plus 6s times r. Notice I didn't include any initial conditions, and that's okay because with transfer functions, you often ignore them. So now I got to do some factoring. Factor on my x. Oops, 6s. And then my transfer function is x over r. It's going to be equal to 6s plus 6. That was it for that one. Question on number 4. Fair, not fair?
It was clear.
Most people were able to get this one pretty easily, I think.
If at the meeting was 2s cubed, would you?
2s cubed, so if I had 2x right here,
2s.
well, but I have to put that over here, so that would end up over there.
So now, would you require to remove the 2, divide everything by 2 to get the s cubed by 7?
No, I wouldn't. I probably wouldn't require it here, mainly because you have an s cubed over here, you still have to do a lot of factoring to get it in standard form.
S squared.
No, if you look at the Laplace table, no, there are no s squared elements in there. They're all, no, there are s squared elements, but it's either s or s squared, and those will be multiplied by 1. So unless you have an s squared, and even then, I would probably do an s squared like that. So I don't actually technically have, when I do it in my final form, this is usually always just an s multiplied by 1.
So that you always using the s squared 1.
Yeah, so like I said, if I was doing this, then if I had an s squared, I probably would factor it one more step and do it that way, yeah. Okay, any other questions on number 4? All right, number 5. Free body diagram time. Here's our mass. I'm going to apply a force in this direction. Now I got to figure out what happens. Well, the first thing I know is that I've got a spring, K1, that is happy where it is. It's not putting out any force. All of a sudden, you're pulling it this way. So I've got one force pulling in this direction. That's K1. I also have K2. So K1 is being elongated. It's fighting to go back, but K2 is being compressed. And it's also not wanting to be compressed. So K2 is in the same direction, is it not? Remember, they're happy at the point that they're at. They don't want to change. They want to be in their normal state. Then I have my damper, and my damper just opposes any velocity. So that's always going to be in the opposing direction. And lastly, I've got to accelerate the mass. And again, I'm storing energy, so I'm applying a force. I'm pulling it. It's going to have a force in the opposite direction. So F applied is going to be equal to K1 times X. I don't know why this is going so slowly. Plus K2. I don't know what's happening here. Sorry. Let me see if I get that out of the way. Plus B times X prime plus M. Sure what's going on. So now I go to Laplace domain. F of S is equal to K1 times X plus K2 times X plus B S times X plus M times S squared X. I factor out. So I have X over here. And then I'm just changing the order. S squared M times S squared. Oh boy, this is really making it very difficult. I don't know why I keep switching. So this is M times S squared plus B times S plus, I understand what's going on. Let me see if I can put that over here and see if that stops it. Plus K1 K2. I don't know what is this doing? It's really acting weird today. Like it keeps shifting. It won't stay. So I don't know what's happening here. That equals X. So I actually have that all here. So now I'm just going to go ahead and find F of X. Boy, oh boy. Everything is really working weird here. I don't know what's going on. I love computers. So my position change based on my input is going to be equal to 1 over ms squared plus bs plus K1 plus K2. And then if you wanted to, you could factor out the M. So move that to the numerator. No. I don't know what's going on here. I cannot get this to work. What's that? And that was a final answer. Some people struggled with what to do with the Ks. And you got to be careful. If you said K effective, I didn't tell you where K effective was. So if you just assume K effective was K1 in parallel with K2, because if they're on the same side, right, they respond differently. So there may be a different response. That's why you just couldn't do the K effective that way. Number 5, fair enough there? Reasonably challenging. All right, number 6 is we have a transfer function. Right? Now we have to find the steady state output for a unit step input. Unit step input is 1 over S. So Y of S is equal to G of S times X of S, which is equal to 2 over S squared plus 2S plus 8, multiplied by 1 over S. And now I can do the final value theorem. So Y steady state, this is in the time domain, is going to be equal to using my final value theorem, right? You could have certainly gone back and taken this into taken this to the time domain. So you could have done partial fraction expansion here. And let's just say this is complex. I don't know. But using the final value theorem would have given you better results. So S approaches 0, S times Y of S, which is a limit. As S approaches 0. So S times 2 over S squared. I'm going to throw this computer out the window here in a second. I wish there was a way of locking it because it doesn't seem to want to. Times 1 over S, cancel, cancel. And then as the S goes to 0, all I'm left with is one quarter. Hmm? Well, if you left it as 2/8, I think I would have given you credit anyway, so. And that was the last problem of the test. Fair, not fair? I've been saying it many times in this class, right? If you're trying to find steady state, what did I would say? Use them. I must have said it at least half a dozen times this semester so far.
Right.
You're welcome, though. You could have done this approach here. But you still would have had to take it back to the time domain, and then you have to let T approach infinity. It's just more work. But that would have been giving you the same result. Any questions on the test? Overall thoughts of the test?
Yeah,
Too easy?
No. Oh.
Average was an 88. There are multiple perfect scores.
some problems maybe.
Some problems are too easy.
Well, like the given differential equation, that was pretty straightforward. I would definitely have to see that.
Is that too easy though? There's a difference.
I guess a lot of this is on.
If you didn't know it, it would look like rocks, right?
So I guess, I mean, what you taught in class was, I think it's that, but.
That's what I'm looking for. Is this a reasonable assessment of what you were presented in the class? I don't have to sit here and give you really complex mechanical systems because I just need you to understand how to do system modeling. So if you could do one, I was pretty comfortable with it.
I was surprised it wasn't a multiple. I mean, I know that's pretty close.
To me, they're the same.
Yeah, that's.
Were there not enough problems? Too many problems?
Put it out. Long enough. Maybe longer.
Okay. I'm just trying to gauge because should I make the test harder, easier, the same? Everybody being honest, saying, yeah, this, did you, I just want to make sure that everybody doesn't think that this is just a blow off, I want to make sure that this is actually testing your.
I think it felt easy, mostly just for me, because it didn't, wasn't fully easy, but just because of the review session, melted my brain that we had last week, of going over this when I didn't know it. So like, I feel like I studied.
The review session with Conlon or the review
Yeah.
session with me or both?
Both. But Colin especially, because it was like 3 hours straight, just mind melting.
I watched the video that I was like,
Yeah,
you guys are put through hell.
we were having it.
Yeah,
But then also the kind of the almost because when I was doing this one, I was like, an almost question, final came back. I was like, If we didn't do the homework, let's have this.
Yeah,
It's kind of nice, like, rating the ball.
okay. Any other thoughts or conclusions?
We didn't have many.
What's that?
We didn't have the rest of English, like in the our test, it's wrong.
Yes. I'll see if I can use Google Translator for you, right? If that works. How about in TV land? Any questions for comments for TV land?
I would just say, I didn't think it was too easy. I think we just did a good job reviewing for it between the lab review session and then our last class as well. So I think it was good.
He said he didn't think it was too easy. Yeah, so again, this material is quite different in terms of probably what all of you done in your college careers, so we can adjust the rigor, if you will, by tweaking things a little bit.
Well, again, the other thing is that felony is just how
Prepared you were.
prepared.
So really, the power is in your hands, right? It was easy because you guys had prepared sufficiently for it. Whereas if you had not been prepared, it might have been a very difficult exam. I don't know.
But you had handled this 2 weeks ago. All of those failed.
Yeah, it's
That's weird.
Well, that's good. That's what you've learned. But the other thing too is if you look at the FE review exam, the FE exam, a lot of these types of problems are on the exam. So again, this is really trying to prepare you for the FE. And if you haven't taken 405, the EET class that prepares you for the FE, you know, you would see how this class really will help lead into that class. It's not a requirement, but it definitely helps.
I think it's required.
No. To take that class, you don't need to have 325 done. It's not a prerequisite,
Oh,
but it certainly makes it a lot easier.
they have that up here, but I feel nothing for them.
No, there's one in Augusta, I thought. I mean, they used to have one in Bangor, but they closed that one recently. So, yeah, I don't know. I'm not sure. Yeah. All right, any other questions? All right, you worked hard, so go have fun for 40 or so minutes. Take care, everyone. Have a great day.
Thank you, Paul.
Thanks, Paul.
Thank you.
Came off the back, somebody else's exam.
Oh, okay. Thank you.
Has some work on there, but